Alright guys, Transcended here. So in this video we're gonna go over acid and base titration. Even before we get to look at the questions, it's very important guys to understand that the acid and base titration is also called a neutralization reaction, because you come up with something that is neutral, and what is produced after reacting an acid and a base is a salt plus water. Okay, so a very good example is the reaction that we've been given in the first question there. So let's start. Question 1. It takes 83 milliliters of 0.45 molar solution of sodium hydroxide to neutralize 235 milliliters of an HCl solution. What is the concentration of the HCl solution? So when they say neutralize, it means that the pH is going to be neutral. Okay, so let's try to work this one. So what we need to know is that the concentration is determined as a product, rather as a division of the number of moles by a volume of a solution. Okay, so we need to know that as we get to talk about two different things, even as we get to determine how much is required, we need to look at the reaction itself. So what do we have? We have HCl, the acid, reacting with a base, sodium hydroxide. So this is giving us sodium chloride plus water. Okay, so like I said, a salt and water. So what do we have? So we've been given the volume of sodium hydroxide. So the volume is 83 milliliters. Then we've also been told the concentration is 0.45 molar concentration. So molar concentration means mole per liter. So whenever we're dealing with that as with our calculations, we need to make sure that we convert our volume to liters. Okay, so we'll do that. Then we've also been given the volume of the acid to be 235 milliliters. So now the question is, find the concentration of the HCl if this acid is to neutralize the sodium hydroxide that we have. So what should we do? So in this case, it's very simple to deal with it because they are in the ratio of 1 to 1. So whenever they are in the ratio of 1 to 1, all you have to do is go back to the dilution law, where we are saying the concentration of V1 is going to be equal to for the second one as well. So this formula is telling us that the number of moles of HCl should be equivalent to the number of sodium hydroxide because they are in the ratio of 1 to 1. So our formula is concentration is equal to number of moles over volume. If you make N to be a subject, you have that and this. So let's try to plug in the values that we've been given and we see what we're going to have. So I'll wrap this part of the equation and continue from there. So no need of converting the units that I have because it's a ratio. So what is the concentration of the HCl? We don't know. I'll put a C. The volume is 235. It's supposed to be equal to the other side. The concentration is 0.45 multiplied by the volume, which is 83. So our concentration is going to be 0.45 multiplied by 83 divided by 235. So if you get your calculator, 0.45 multiplied by 83 divided by 235. So what I'm getting is 0.16 molar solution. Okay, let's move on to the second question. You are titrating an acid into a base to determine the concentration of a base. So you are having a mixture of an acid and a base. That's the question. So you are titrating an acid into a base to determine the concentration of the base. So meaning that the concentration of the acid is known. So the acid concentration is known. Alright? So we are trying to determine the concentration of the base. So that's a piece of information that we have. So the end point of the neutralization is reached, but the stop cork on the bullet sticks straightly and allows a few more drops of acid to fall into the solution. How will this affect your calculations for the concentration of the base? So the way this one works is titration, you're going to have a bullet there. It has a tap. Okay. Then you have a beaker there, and that's where you've put your base. You have your acid there. So you know the concentration of the acid. So you're trying to determine what volume is required. Okay. And you're going to determine that by looking at the endpoint of the color change, depending on the indicator that you're working with. Let's say maybe colorless to orange. When immediately turns orange, you need to cross the tap there. Okay. So now you use the burette by using the initial and the final for you to determine how much of the acid was required by the base. So the higher the concentration of a base, the higher the amount of acid that is going to be required to be neutralized. Okay, so how will this affect? So the tap refuses to close after reaching the end point, meaning that you're going to have more acid there in the base. And this is going to make you overestimate how much of the acid was required. So you're going to determine a concentration that is higher than the one that is required, because it is going to seem as though the base required a lot of acid. Okay, so we can say that we are going to overestimate the volume of what? The base. For a third question, it takes 38 milliliters of 0.75 molar solution of sodium hydroxide solution to completely neutralize 155 milliliters of a sulfuric acid solution. What is the concentration of sulfuric acid? Okay, so we need to come up with the reaction there. So what do we have reacting? We have H2SO4 sulfuric acid reacting with sodium hydroxide, the base, giving us, so in this case the salt is going to be sodium sulfate. Now sulfate has got a valence of 2, so it's going to be sodium 2 sulfate plus water. Okay, so we need to balance this. Is it balanced? It's not balanced. Why is it not balanced? Because we have sodium 2 there, so here we need to put a 2. Okay, so the moment you put a 2 there, it will require how many hydrogen atoms? 2 plus the 2 here, 4. So we need to put a 2 there as well. So that is the balanced equation. So how can we determine the concentration of the H2SO4? So the same formula is going to work, but this time around we need to note that the ratio is 1 to 2. So things are going to be a bit different in this case. So let's work with what we've been given. So for sodium hydroxide, we've been given information like the volume is 38 milliliters. Then we've also been told the concentration is 0.75 molar solution. So that volume is supposed to be taken to liters. So you divide by 1,000. 38 divided by 1,000, we're going to have 0.38 liters. So we have our volume, we have our concentration. Oh yes, we have our concentration. We can determine the number of moles. So the number of moles is going to be a product of the concentration and the volume. So 0.75 multiplied by 0.38. So what I'm getting is 0.285 moles of sodium hydroxide. But for us to neutralize the acid, what we need to make sure is that the number of moles of the base is supposed to be equivalent to the number of moles of what? The acid. Okay. So now, what we have is the number of moles for sodium hydroxide. But if you look at the ratio that we have, it's 1 to 2. So meaning that 1 mole of sulfuric acid requires 2 moles of the sodium hydroxide for it to be neutralized. So since we have 0.285 moles, how many are going to be required? Okay, how many are going to be required? So we need to find x there. So if you cross and multiply your 2x, it's going to be 0.285. So this is going to be half of it, which is 0.1425. So 0.1425. So these are the number of moles of H2SO4 that are required to neutralize what? The sodium hydroxide. But then, what information I've also been given about the H2SO4? We've been given the volume to be 155. So 155 milliliters is supposed to be converted to liters by dividing by 1,000. So 155 divided by 1,000, what we have is 0.155 liters. So we have our volume. We've also determined the number of moles. What are we able to do? We are able to find the concentration. So concentration is the number of moles dissolved in a given volume. So we have number of moles to be 0.1425 divided by, so these are the moles. Our volume is 0.155 liters. Okay, so if you get your calculator and plug in the values there, what are we going to have? So 0.1425 divided by 0.155. What I'm getting is 0.1, it's actually 0.92 molar solution of what? H2SO4, or sulfuric acid there. So we've determined now the concentration that is required of a sulfuric acid for it to be successful in neutralizing there. Okay. Question 4. A few drops of water are left in a bullet that is then used to titrate a base into an acid solution to determine the concentration of the acid. Will this small amount of water have any effect on the determined value of the concentration of the acid? If so, how is it affected? Okay, so yes, even this small amount of water will cause an error because the drops of water will add to the volume of the base. So actually diluting it slightly. Okay, so this means it will take a more base solution to neutralize the acid, making it seem as if the acidic solution was of stronger concentration than it actually was. Okay, so you have a bullet there. So then there's some water that had remained there. So then there's a base there. So you're trying to now titrate that into what? Into the acid. So you already know the concentration of the base. So you are trying to determine now the volume. So the way it's going to be is, since it's going to be slightly diluted, more of it is going to be required by the acid. So meaning that we are going to determine a value of the acid that is actually bigger. Okay. All right. Let's move on. It takes 12.5 milliliters of 0.3 molar concentration of HCl to neutralize 285 sodium hydroxide. So whenever you're dealing with a neutralization reaction of an acid and a base, make sure you come up with an equation, write the products. So it becomes very easy in a case where they're reacting in the ratio of the mole ratios are 1 to 1. So the products here are sodium chloride and water. Okay, so in this case we work with this formula for the dilution law. Okay, since the mole ratios are the same. So what is the concentration of the HCl? It's initially 0.3. So work with 12.5. What is the concentration? We don't know, but we know its volume to be 285. So our concentration of sodium hydroxide is going to be given as the product of that by 12.5 divided by 285. So get your calculator. 0.3 multiplied by 12.5 divided by 285. So what I'm getting is 0.013 molar concentration of what? Of sodium hydroxide. So what is important, guys, in summary, what we're saying is for us to have a complete neutralization between an acid and a base, their number of moles are supposed to be equal. Okay. So the reason why we are saying this is the formula that we are working with is because we are saying the number of moles of the base is supposed to be equal to the number of moles of what? The acid. And this usually tends to work when you have the same number of what? They are in the ratio of 1 to 1 in the equation. In the case where it's different, you're supposed to work with a formula that is going to introduce now the number of what? The number of moles. So the way you do it when you have got different number of ratios, for example, like we had sodium hydroxide with sulfuric acid, it was in the ratio of here you have sodium hydroxide, so it required 2 of that. So the ratio were 2 to 1. So in this case, it's supposed to be C1 V1 over 2 being equal to C2 V2. So meaning that you're supposed to divide by the coefficient of the stoichiometric coefficient in the equation. Finally, the last question. Lulu Lableka carefree pipettes 25 milliliters of 0.525 molar concentration of sodium hydroxide into a test tube. She presses the test tube into a small beaker to keep it from spilling and then pipettes 75 milliliters into another test tube. So when Lulu reaches to put the test tube of an acid into the beaker along with the test tube of the base, she carefully accidentally knocks the test tubes together hard enough to break them, and their respective contents combine in the bottom of the beaker. So is the solution formed from the contents of the two test tubes acidic or basic? So what concept are they trying to test us here? They're trying to find out whether we've understood the acidic and the basic solutions, titrations. So we need to come up with an equation. What do we have? So in the other test tube, we had sodium hydroxide. In the other one, we had HCl. So it's a neutralization reaction. So it's going to be sodium chloride plus water. So this is the reaction that we're going to have. Now, what have we been given? We've been given the concentration and volume of both sodium hydroxide and HCl. So what is going to help us work out this is by determining which one is going to be the limiting reagent, so that we determine how much was left over after the reaction. And what was left over will determine whether it's going to be basic or acidic. In a case where the acid is in excess, the reaction or the solution will be acidic. If the sodium hydroxide is in excess, it's going to be basic. Okay, so let's determine the number of moles. Since sodium hydroxide and hydrochloric acid are in the ratio of 1 to 1, the number of moles are supposed to be equal for us to have a neutral solution. So let's try to determine the number of moles that we have. I'll start with sodium hydroxide. So if you check what we've been given there, what is the number of moles of the concentration of sodium hydroxide? It's 0.525. So 0.525. Then the volume has been given to be the volume has been given to be 25 milliliters. So that volume that you've been given, divide by 1,000 so that you have it in liters. Okay, so it's going to be 0.025. So therefore the number of moles are going to be 0.025 multiplied by 0.525. What I'm getting is 0.013125. So these are the number of moles of what? Of the sodium hydroxide. I'll use a different color for the HCl. So the number of moles of HCl, what is this concentration? The concentration was given to be 0.355. What is the volume? 75 milliliters. So the 75 is supposed to be divided by 1,000, and what I'm getting is 0.075. So if you multiply 0.075 by 0.355, what am I getting? I'm getting 0.026625. Okay, so these are the number of moles of HCl. So now, if you look at the two, which one is bigger? So the one that is bigger is the HCl. Okay, so meaning that sodium hydroxide was the limiting reagent because it can finish faster, because these are supposed to be equal because they are in the ratio of 1 to 1. So determined our limiting reagent. So we need to subtract the excess reagent minus the limiting so that we see how much was in excess. So we have that subtracting 0.013125. So we have the excess number of moles subtracting the limiting number of moles. So if you subtract, what I'm getting as the number of moles of the acid that are in excess is okay. So I'm getting number of excess HCl. So let's have some space here. I'm getting 0.0135. So remember, what was in excess is the acid. HCl had greater number of moles than this, the base, sodium hydroxide. So these are the number of moles of what? Of HCl in excess. Okay. So this is determining the pH of the solution, meaning that it is acidic. So the pH is determined as a negative log of what? The concentration of the acid. Okay. So negative log of that. So the concentration. So we have the number of moles there. So we need to divide by the volume. So the total volume in this case, if you add what we had 25 being combined by 75 milliliters. So 25 plus 75. So 25 was for the sodium hydroxide, then 75 was for the HCl. What I'm getting is 102. So we need to divide the 102 by 1,000. So what I'm getting as volume is, so let me write down. So 75 mils plus 25 mils. It's 102 mils. So we need to convert that milliliters to liters. So after dividing by 1,000, it's 0.102 liters. So you need to divide the number of moles by the liters for you to get what? For you to get the concentration. So 0.0135 moles divided by 0.102. What I'm getting is 0.132 as a concentration. So negative log of that. So what I'm getting as the pH of a solution is 0.88. Okay. So this tells us that the solution is what? Is acidic. So thank you very much for watching and have a good day.